Hello viewers, welcome to my YouTube channel. I'm excited to share another informative video with you today. So if today is your first time of watching my video, please take a moment to subscribe to my YouTube channel and press the notification bell so as for you to receive a new video that we're going to be uploading on this channel. So now let's dive into today's topic, indices. So indices is an area of mathematics where we study power of a number. An indices is the plural of index. So at the end of the activities today, you will be able to define index and the base of a number. You will be able to discuss different law of indices. You will be able to evaluate expression using the law of indices. So the word index is referred to as the power or exponent raised to a number or variable. Indices is the plural of index, which is also known as power or exponent. Therefore, indices simply means the study of what? Of exponent. Now, when we're talking about index notation is a way of shortening the product of equal factor of a number. For instance, if I have 2 raised to power 5, 2 raised to power of 5 is regarded as an index form of number. Now, to express this in an expansion form or expanded form, that means that 2 multiply itself 5 times. Now, we can also make use of a variable, a letter. So if I have a raised to power 5, this implies that a multiply itself 5 times. Now, let's take for instance, if I have 5 raised to the power of n, 5 raised to the power of n implies that 5 multiply itself by n times. N times simply means number that is not what? An index that is not given. So this could be 5 times infinity. That is n times. N times could stand for 5, 6, 8, 9, as the case may be. So n is your index. And 5 raised to the power of n is regarded as an index notation. And when we have this expression, 5 raised to the power of n, your 5 is regarded as your base and your n is regarded as your index, which could be any number. Now, 4 is regarded as your index, power, or exponent, and your 2 is regarded as your base. So please note that each number naturally has an index of 1, but we do not write it because it does not denote any change of value mathematically. If the index is anything other than 1, then you are required to write it down as the power of the word of the base given to you. The index of number can also be 0 or negative. So as we proceed in this class, we're going to discuss this extensively. Laws of indices. The laws of indices are a set of fundamental rules that govern the way index or indices are to be dealt with. Indices are not just used to improve the ease of writing the number mathematically, but also have a specific function, and therefore these indices rules are very important in solving the algebraic indices problem. So now let's look at each law of indices formula with an example to interpret each law. So we're going to start with the multiplication law of indices. Multiplication law of indices. So if I have this expression, a raised to the power of n times a raised to another power of m, this implies that a, which is the base, since the index notation are both having the same base, therefore I'm meant to add up my index n and m. So this multiplication law of indices implies that when expressions with the same base are multiplied, the indices m and n are to be added. So we have an example here. If we have 6 raised to the power of 3 times 6 raised to the power of 4, this implies that 6 is raised to the power of 7. How did we come across this? Let's explain this more bit. So if I have 6 raised to the power of 3 times 6 raised to the power of 4, this implies that 6 multiply itself 3 times. Let's put this in brackets. Times 6 again multiply itself 4 times. Now, if we open the bracket here, we're going to be having 6 times 6 times 6 times 6 in 7 places. So now let's count this number of 6 that we have here. We have 1, 2, 3, 4, 5, 6, 7. So this implies that 6 is raised to the power of 7. In other words, to write this in an easier form, I can just say 6 is raised to the power of 3 plus 4. Since they are having the same base, I can only do this when my index are having the same base. So 6 raised to the power of 3 plus 4 will be 6 raised to the power of what? Of 7. Only if the examiner asks you to leave your answer in an index form. If the examiner does not want you to leave your answer in an index form, you can proceed by saying 6 raised to the power of 7. And 6 raised to the power of 7 is going to be 279,936. Now, this expression now is regarded as the expanded form. This expression here is regarded as the index form or index notation, and this answer here is regarded as the expanded form, of which you have to what? Express what the 6 raised to the power of 7 is. Now, it should be noted that this rule only applies to indices with a common base. That's when you can what? You can add up your number. We cannot simplify 3 raised to the power of 11 times 4 raised to the power of what? Of 7, as 3 and 4 are different base numbers. Now let's take some exercise. We've already answered this. 6 raised to the power of 4 times 6 raised to the power of 3. I'm going to take 2 more examples, and you are going to take the next one as your exercise. So let's try 8 raised to the power of 7 times 8 raised to the power of 10 times 8 raised to the power of 1. Don't forget, I told you that every number naturally have an index of what? Of 1. Every number naturally have an index of 1. So if I have 8 raised to the power of 7 times 8 raised to the power of 8 raised to the power of 10 times 8 raised to the power of what? Of 1. But we might not indicate the index of 1 here. Now, what does this mean? Using my multiplication law of indices, since I'm having the same base of 8, I'm just going to add up my what? My index. Therefore, I'm going to be having 8 raised to the power of 7 plus 10 plus 1. Don't forget, I told you that every number naturally have what? An index of 1. So our final answer is going to be base 8 raised to the power of 7 plus 1 is 8. And 8 plus 10 is going to give us 18. So this implies that 8 is raised to the power of what? Of 18. So you can leave your answer in index form, provided the examiner wants you to leave your answer in index form. And if the examiner does not want you to leave your answer in index form, you find or you express your number in an expanded form. So let's take other example. If I have a raised to the power of 2 times a raised to the power of 3, this will be a times a, close the bracket, times a times a times a. So I'm having a times a times a times a times a in 5 places. So this implies that a is raised to the power of 5. A is raised to the power of 5, and that's going to give me my final answer. And if I want to apply my multiplication rule of indices, I'm going to be having a raised to the power of 2 plus 3, since they are having the same base, and this will be a raised to the power of 5. Now, take a look at this number. 2 raised to the power of 4 times 3 raised to the power of 2. We cannot simplify this expression because they are not having the same base. Their base are not the same. So this expression cannot be simplified. But if I'm having 2 raised to the power of 4 times 2 raised to the power of 2, this implies that 2 will be raised to the power of 4 plus 2, and that will be 2 raised to the power of what? Of 6, leaving my answer in what? In index form. And you can still proceed by expressing your number in an expanded form. And to express this in expanded form, your answer is going to be 64. That's when you are asked to leave your answer in an expanded form. So now let's move to division rule of indices, and we can also call it quotient rule of indices. This law is needed when expression with the same base are divided. Then the indices m and n are to be subtracted. Division rule of indices is applied when expression with the same base are divided. The indices m and n are to be subtracted. Let's take, for instance, we have 6 raised to the power of 7 divided by 6 raised to the power of 4. What does this imply? We have 6 raised to the power of 7 minus 4, and that's going to give us 6 raised to the power of 3. Leaving your answer in expanded form, you're going to be having 216. Let's take, for instance, we have 6 raised to the power of 7 divided by 6 raised to the power of 4. What does this imply? This implies that 6 multiply itself 7 times. This is 6 times 6 divided by 6 times 6 times 6 times 6. Now, By division rule, we cancel out 6. From this place, we have 6 cancel out 6, 1, 6 cancel out 6, 6 cancel out 6, 6 cancel out 6. So we are left with 6 times 6 times 6 over 1. So this implies that 6 is raised to the power of what? Of 3. Now, leaving my answer or writing my answer in expanded form, I'm going to be having 6 times 6 times 6 times 6. That is 6 in 3 places. And my final answer is going to be 216. Leaving my answer in what? Expanded form. So let's consider this expression here. If I have 8 raised to the power of 7 divided by 8 raised to the power of 4, I can re-express my question as a quotient by having 8 raised to the power of 7 over 8 raised to the power of 4. Now, we expand the numerator and the denominator. So how many 8 we cancel from the top and the bottom? Since 8 is raised to the power of 7, we are having 8 times 8 times 8. We are having 8 times 8 times 8 times 8 times 8 times 8 times 8 in 7 places, divided by 8 times 8 times 8 times 8 in 4 places. So we cancel out 8 from the numerator and the denominator respectively. So if we are to cancel out 8 from the numerator and the denominator, we are going to be left with 3 8. And having 3 8, we are going to be having 8 raised to the power of what? Of 3, which is the index of 8 times 8 times 8. And 8 raised to the power of 3 is going to give us 512. That's if you're asked to leave your answer in expanded form. So let's take a look at this exercise we have here. In a case whereby you have a large index, you cannot express your question in expanded form before cancelling out and getting your answer. So the best thing for you to do is to apply your indices rule. For instance, if I'm given 5 raised to the power of 200 divided by 5 raised to the power of 150, we cannot go on by saying 5 times 5 times 5 in 200 places. So instead, it's better we apply our indices rule. Since the bases are the same, we apply our division rule of indices by saying 5 raised to the power of 200 minus 150. And 200 minus 150 is going to give us 5 raised to the power of what? Of 50, which is going to give us our final answer. And of course, if you are meant to express 5 raised to the power of 50 in an expanded form, your number is going to be a very large number. So we leave our answer in index form. So you can try other question here to see if you have already mastered the knowledge of division law of indices. So let's move to the next rule, which is negative index. Law of negative index, or you call it law of negative indices. Now, if I have a, which is my base, raised to the power of minus m, a, which is my base, raised to the power of minus m, this can be re-expressed as the reciprocal of a raised to the power of m. That is, I'm going to be having 1 over a raised to the power of m. Now, if a term has a negative index, that is a negative power or negative exponent, It can be represented as reciprocal with the positive index as its power. That is, if I have 2 raised to the power of minus 3, I can re-express this as 1 over 2 raised to the power of 3. That is, my negative value is going to be cancelled, and this can be expressed in fraction form as 1 over 8. That is 2 times 2 times 2. That's 2 in 3 places. That's 2 times 2 for 4 times 2 is 8. So my final answer is going to be 1 over 8. Provided the examiner express his or final answer as fraction. If the final answer is not expressed or given in final answer, it can be written as 8 raised to the power of minus 1. So, if we have this expression, 5 raised to the power of 3 divided by 5 raised to the power of 7, this can be re-expressed as 5 times 5 times 5 over 5 times 5 in 7 places. So if we cancel out 5 from the numerator and 5 from the denominator 3 times, so we're going to be left with 5 times 5 times 5 times 5. And this implies that we're going to be having a negative exponent, which can be expressed as 5 raised to the power of minus 4. And if I'm meant to leave my answer in a reciprocal form, my final answer is going to be expressed as 1 over 5 raised to the power of 4. Let's take some exercise here. If I have 2 raised to the power of minus 5, 2 raised to the power of minus 5 can be expressed as 1 over 2 raised to the power of what? 2 raised to the power of 5. And if the examiner wants us to leave our answer in expanded form, you're going to be having 1 over 32 as your final answer. 1 over 32 will be your final answer. If you have a raised to the power of minus 3, this can be expressed as 1 over a raised to power 3, and this implies that a over a times a times a. That's what it implies. Now let's take number. If we have 2 raised to the power of minus 3, this means that we're going to be having 1 over 2 raised to power 3, and this implies that your 1 over 2 raised to the power of 3 is going to give you what? 8. That's it. You have your what? Your final answer. Or you can re-express your final answer as 8 raised to the power of minus 1. 8 raised to the power of minus 1, as the case may be. Let's take other example. If I have 3 raised to the power of minus 6 times 3 raised to the power of 9 divided by 3 raised to the power of minus 5. This expression now has a combination of both multiplication, division, and negative index rule of indices. So let's solve this question together. Having this question, we need to take it one after the other. Since we're having the same base of 3, we can proceed by saying 3 raised to the power of minus 6 plus 9 divided by 3 raised to the power of minus 5. 2 raised to the power of minus 5. Now, I'm going to be having 3 raised to the power of 9 minus 6 divided by 3 raised to the power of what? Minus 5. So this will be 3 raised to the power 3 divided by 3 raised to the power minus 5. So if I want to express my answer, I'm going to be having 3 raised to the power of 3 minus minus 5. I'm going to put this in brackets. And don't forget, minus times minus is equals to what? To plus. So my final answer is going to be 3 raised to the power of 3 plus 5. And 3 plus 5 is going to be 3 raised to the power of what? Of 8. And 3 raised to the power of 8 is going to give us 6,561. That is 6,561 is going to be 3 raised to the power of 8. Let's take other question. If I have 7 raised to the power of minus 4, so if I have 7 raised to the power of minus 4 times 7 raised to the power of 3 divided by 7 raised to power 8 times 7 raised to minus index of minus 2. So I can take this one after the other by applying my indices rule. So let's apply the multiplication rule first. So this will be 7 raised to the power of minus 4 plus 3 divided by 7 over 8 plus minus 2 plus minus 2. Let's put this in brackets. So we're going to be having 7 raised to the power of minus 1, because minus 4 plus 3 is going to give us minus 1, over 7 raised to the power of 6. Now let's take our division rule. If I'm having 7 raised to the power of minus 1 divided by 7 raised to the power of 6, this will be equals to 7 raised to the power of minus 1 minus 6 minus 1 minus 6, and this will be equals to 7 raised to the power of minus 7. 7 raised to the power of minus 7. And this can be re-expressed as 1 over 7 raised to the power of what? Of 7. And we can leave our final answer as 7 raised to the power of 7 is going to give us 823,000 and 23,543. That should be our final answer, provided the examiner wants you to leave your answer in expanded form. Okay, so let's move to another aspect. 6 raised to the power of minus 2 over 3 raised to the power of minus 3. Now if you take a look at this expression, they are not having the same base. So all we need to do is to express either one of them to be having the same base. Now let's consider the number 6. What are the factors of 6? 3 and 2. 3 and 2 are the factors of 6. Then we still have our what? Our exponent minus 2 over 3 raised to the power of minus 3. So I can re-express this as 3 raised to the power of minus 2 times 2 raised to the power of minus 2 divided by 3 raised to the power of minus 3. Now, considering my Bodmer's rule, I'll be having 3 raised to the power of minus 2 times 2 raised to the power of minus 2 divided by 3 raised to the power of minus 3. So I can express this as 3 raised to the power of minus 2 divided by 3 raised to the power of minus 3 times 2 raised to the power of minus 2. So recall that the division rule in indices changed towards to minus. So I'll be having 3 raised to the power of minus 2 minus minus 3. Let's put this in bracket times 2 raised to the power of what? Minus 2. Now, recall that minus times minus is equals to what? To plus. Therefore, we'll be having 3 raised to the power of minus 2 plus 3 times 2 raised to the power of minus 2. So this will be 3 raised to minus 2 plus 3 will give us 1 times 2 raised to the power of minus 2. And we can re-express this as 3 over 2 raised to the power of 2. And this will be equals to 3 over 4. 3 over 4 is going to be our final answer here, provided the examiner wants you to leave your answer this way. Let's take one more example. If you are given 7 raised to the power of 7 times 7 raised to the power of minus 6 divided by 7 raised to the power of 10 times 7 raised to the power of minus 11. Applying our multiplication rule and division rule and negative index rule, we're going to be having 7 raised to the power of 7 plus minus 6 divided by 7 raised to the power of 10 plus minus 11. So this will be 7 raised to the power of 7 minus 6 will give me 1 divided by 7 raised to 10 plus minus 11. 10 minus 11 is going to give me minus 1. So in this case, to express this using my division rule, I'm going to be having 7 raised to the power of 1 minus 1. Put this in brackets. Recall that minus times minus is equals to what? To plus. So I'm going to be having 7 raised to the power of 2. And this implies that my final answer is going to be 7 times 7. 7 times 7 is going to give me 49. And that's going to be my final answer. So, having the answer here, we've already gotten our answer to this example. So, at your own leisure time, I also want you to try this particular question here to see if you have already understood the concept of indices. That is the multiplication rule, the negative index rule, and the division rule, as the case may be. So we also have this. You can try this. The question says find the value of 3 raised to the power 3. And this implies that you have 3 times 3 times 3. And 3 raised to the power of 3 is going to give you 27. So that's how you're going to do the other one. Then in the case whereby you have a negative number, you have to express your number as a fraction. So like this 0.69 is going to be 6 over 10. 6 over 10. 6 over 10 raised to the power of what? Of 2. And the other one is going to be 0.1. That will be 1 over 10 raised to the power of what? Of 2. So you solve. And this one, then you reconvert your answer back to what? Index form, as the case may be. So watch out for our lesson 2, that is other laws of indices. So if you have not subscribed to our YouTube channel, kindly subscribe to our YouTube channel and press the notification button to receive every new video we're going to be uploading on our channel.